Now that we've introduced some popular voting methods, we're going to look at the flaws of those 4 popular voting methods. And then in the future video, we'll get into some other types of voting methods that can help offset some of these flaws a little bit. All right, no voting method is perfect, but if you want to consider a voting method to be fair, they need to meet 4 criteria. And we're going to go through each of these and see examples of what they mean. 4 criteria include majority criterion, the head-to-head criterion, the monotonicity criterion, and the irrelevant alternatives criterion. So let's tackle that majority criterion first. According to the majority criterion, it makes the most sense that if somebody receives the majority of votes, they should be the winner. No matter what voting method you apply, this criterion is saying if somebody had a majority of votes, they should win through the other methods as well. But this doesn't always happen. Okay, now if you use plurality, you're good, because plurality picks the person with the most votes. The person with the most votes, if they have over half, they are the winner. Plurality with elimination, by its very definition, you are trying to find the candidate with the majority votes anyways. So, of course, the winner there is going to meet this criterion. The pairwise comparison methods also will meet this criterion. If somebody has a majority of votes, if you try to apply the pairwise comparison method, you'll get the same winner. But Borda count is the one that potentially violates this. It is possible that the person who has the majority of votes may not win by the Borda count method. It all depends on those rankings and how many, not just how many first place votes there are, but how many second place votes. You could have a candidate who has a lot of second place votes, which might help bump them up in Borda count to be the winner, even though they didn't have over half of the first place votes. So that's where this is potentially violated. So I wanted to go through and do an example and show an example where majority criterion gets violated. All right. Let's say you have a preference table. We're familiar with preference tables now, where you have rankings, just things are ranked top 3, first, second, and third. Okay, and you have 4 voters who ranked A, C, and then B. You have 3 voters who ranked C, B, then A. You have 1 who said B first place, C second place, A third place, and you have 1 who said A, B, C. So notice you have 9 voters. You might need to know that a little later because you're thinking about majority, so you got to know what over half is. Half of 9 is 4.5, so majority needs at least 5. You're not going to get half a vote. All right. So I'm just double checking when I copied this correctly before we move forward. Okay. So by first place votes, who wins by majority? Well, A has 4 voters who put, nope, 4, I messed that up, not 4, 5. I just saw the other one. For some reason I didn't see that a minute ago. You've got the 4 that placed it in first place in that first column, and you have the 1 that placed A in first place in that last column. So there's 5 voters that chose A first. B, there was 1 voter that chose B first, and then C, there was 1 voter. So A is the winner by majority, because A has 5 votes. That's the most, and that's over half the votes. Now, what if we took the same one and did the Borda count method? Okay, so Borda count method, remember, awards points based on how many first place votes, how many second place votes, how many third place votes. All right, so we have 3 candidates, A, B, and C. For third place votes, we're going to give 1 point each. So remember, the bottom gets 1 point, and then you work your way up. For second place votes, they're going to get 2 points each. And then for third place votes, they're going to get, or for first place votes, why did I say that? Sorry. Once again, there's a lot of noise going on in my kitchen or something right now. I'm trying to figure out what's going on. It's late. All right, first place votes, you're going to get 3 points each. All right, so A had 5 first place votes, 0 second place votes, and then 4 third place votes. There's 9 votes 9 voters altogether, so 4, 0, and 5 is 9. All right, B had 1 first place, 4 second place, 4 third place. So B had 1 in first place, 4, because of 3 in the 1, 4 for second place, and 4 for first place. All right, then C has 3 first place, 5 second place, 1 third place. So 3, 5, and 1. Okay. So we got to add those up and see what's going on there. So A, you have 4 plus 0 plus 15, which is 19 points. B, you have 4 plus 8 plus 3, which is 15 points. Then C, you have 1 plus 10 plus 9, which is 20 points. C is the winner, because C had the most points. C wins by board account. But what did we say up here by majority? We said A had 5 first place votes, so A won the majority here, and the plurality because they have the most votes. So A won by majority. C won by board account. This violates the majority criterion. So there's an example. Remember we said that the other 3 voting methods will never violate this criterion, but board account can potentially violate it. Won't always violate it, but has that potential. And in this example, it fulfilled that potential and violated. Okay, next one, head-to-head criterion. This one says if you put your candidates head-to-head, whoever wins from that comparison should be the winner no matter how you tally the votes. And also known as the Condorcet criterion, is named for Marquis de Condorcet, a mathematician who analyzed voting methods and discovered that sometimes there is no such thing as a clear and fair winner in an election. This is never violated by the pairwise comparison method. Because if you think about it, when they talk about putting the candidates head-to-head, that is exactly what the pairwise comparison method does. It puts the candidates head-to-head to figure out the winner. It does all the points and everything. So, of course, it's not going to violate this. But there is the potential for plurality, border count, and plurality with elimination to violate it. Doesn't say they always will, just they have that potential. All right, and then before I move on to an example, don't forget that if you see a name like Marquis de Condorcet, go ahead and add him to your mathematician list and get your bullet points listed there. Okay, so let's do an example. Okay, so another preference table. We have first, second, and third place. These voters got to rank their preferences. We had 4 voters that put A first, B second, C third. We have 3 voters that put B first, C second, A third. And we have 3 voters who put C first, B second, A third. So there's our preference table. So ABC, BCA, CBA, 4, 3, 3. All right, so since we are looking at the head-to-head criterion, let's first see who wins the pairwise comparison method. So whoever wins that, ideally, should win no matter what. But we know now that that's not always going to happen. That's why we're talking about this. Let's see, you have 3 choices to vote on. So that means you have 3 times 2, which is 6 divided by 2, which is 3 pairings you got to worry about. You got A versus B, A versus C, and B versus C. Okay, so A versus B. How many times did voters rank A higher than B? Let's see, in the first column, 4 voters ranked A higher than B. But in the second and third columns, they ranked B higher than A. So you have 4 that ranked A higher than B, but you have 6 who ranked B higher than A. Yeah, notice there's 10 voters. Okay, so B gets a point. So remember, we have to award points. All right, now for A versus C. In the first column, A is ranked above C, but in the second and third columns, C is ranked above A. So this looks a lot like the other pairing. So C wins out on this one. C gets a point. Because there are 6 votes where C came above A. Then B versus C. So A is going to have 0 points. Oh, poor A. All right, B versus C. In the first 2 columns, B is ranked above C. In the last column, C is ranked above B. So we have 7 votes where B is ranked above C. And then we have 3 votes where C is ranked above B. So B gets another point. Yeah, B is above C for 7. C is above B for 3. All right. So in this one, B had the most points. So B is the winner in the head-to-head comparison. So according to this head-to-head criterion, no matter what other voting method we use, B should still come out the winner. But as we learned, it's not always going to happen. And since, it has the potential to be violated by plurality, border count, and plurality with elimination methods, let's keep it simple and tackle this with plurality. Plurality is nice and easy. A had 4 first place votes, B had 3, C had 3. Remember, plurality is just simply who has the most votes. It does not have to be the majority. It's not until like plurality with elimination that you got to worry about majority vote. All right, so A is the winner here. Oh, man. So in this one, B wins the head-to-head comparison. But A wins by plurality. So this violates the head-to-head criterion. You're going to find that often these names make a lot of sense. You know, head-to-head criterion, you're looking at whoever wins the head-to-head comparison should be the winner, you know, that kind of thing. So it's kind of, some of these names will help give you a hint about what's going on in these comparisons or these criteria, that kind of thing. All right. Next one, the monotonicity criterion. This one talks about, like, if you have multiple elections, let's say you have somebody who wins the first election, adds to their original support, and then runs in the second election. Well, they should be the winner in the second election according to this criterion. Doesn't always happen, though. The plurality method is the only one that will always satisfy this. If you came in first place by plurality in the first election, and you gained support before the second election, you'll still come in first place by plurality. But with plurality with elimination, with Borda count, and with pairwise comparison, it is possible that, depending on how the support was gained, you could win the first election but then not win the second election. It does happen. It's wild, but it does happen. Okay, so let me pull up an example here to do with that one. All right. Let's say we have 17 voters with these rankings. We have 6 that ranked A, C, B for their votes. We have 5 that ranked BAC, B-A-C. We have 4 that ranked CBA. And we have 2 that ranked CAB, C-A-B. So 17 voters. All right, so first let's see who would win by plurality with elimination. So plurality with elimination, we look at first place votes, and we want to see if anybody has the majority. In this case, majority, see, half of 17 is 8.5, so majority would be 9 or more. A has 6 first place votes, B has 5, C has 6. So nobody has the majority. So remember, with this method, we go through, and whoever had the fewest votes gets bumped out. So B gets bumped out. And then now it's just first and second place. So now A has 6, 5, that's 11 of the first place votes. C has 6 of the first place votes. So this time, so we can see that A would win this. All right. But let's throw in a little change here. Suppose that two people change their votes. Originally, they preferred C over A to over B, and they decided at the last minute. So those two that voted CAB, CAB, at the last minute decided to change their ballots to say ACB instead. So basically, that last column is going to get thrown into the first column this time. All right. So the CAB votes are going to change to ACB votes. So let's do a new preference table. So now we're going to have 8 that prefer ACB. And then we still have the others. We still have 5 for BAC, BAC. We still have 4 for CBA. But remember, we got rid of that final column because those 2 votes, CAB, went to ACB now. I'm just double checking my work here, make sure I'm copying everything down correctly. All right, so now let's do plurality with elimination again. All right, A this time has 8 first place votes. B has 5. C has 4. So what happened here? A gained support. C lost support. But with 17 voters, we still need 9 or more. Okay? So C lost support in this new election. A gained it, but it wasn't enough. Remember earlier, we were doing plurality with elimination. We needed, with 17 voters, we needed at least 9 or more votes. So let's see what happens when we throw out C, because C has the fewest votes at this point in this process. So we throw out C. And now A comes in first place 8 times, but B comes in first place 9 times. B is the winner. Wow. Isn't that interesting? Earlier, A won by plurality with elimination. A gained support. It gained some of C's votes. And in the second election, B pulled ahead and won. But it all had to do with the fact that we're using plurality with elimination. And when we eliminated that C in this next go-around, that bumped B up to get some of those other votes. Stuff like this happens like even in our presidential election type situations from the U.S. Way back when, I remember this happening with Ross Perot. Ross Perot, like, I'm trying to remember who all was running during that election. I just remember the name Ross Perot for sure. But one candidate seemed to be winning. There was 3 candidates: the Republican, the Democrat, and Ross Perot. One of the candidates was leading, seemed to be probably a sure bet to win. Ross Perot dropped out, and then that other candidate won instead. Because what happened was when Ross Perot dropped out, Ross Perot supporters were now voting for that other candidate who was not in the lead originally. So that's kind of an example of what's happening here. As soon as C dropped out in this scenario, suddenly that support for B came from that third column there. And then B pulled ahead and won. Interesting, right? So A won the first election. Oops, I'm writing black. A gained votes. B won the second election. It wasn't like B gained a bunch of votes. It was just the way everything was with the plurality elimination method when we eliminated C. So this violates the monotonicity criterion. Interesting, isn't it? All right. So let's go back now. Just looking it over, making sure all my numbers look good. Make sure, I'm trying to think if there's any other questions you might have that, even though this is a video, that maybe, nope. Okay, last criterion. Irrelevant alternatives. The winner of a second election should be the same as the winner of the first election in the event that one or more candidates were removed for the second election. All 4 voting methods discussed have the potential to violate this. Interesting. All 4. It's like if you already won and then somebody else was thrown out. So this is kind of a version 2, like of what I was talking about with the Ross Perot. Like suddenly somebody seemed to be winning, somebody else leaves, and then suddenly that same person should still be winning, but it all has to do with the way the support is tallied. All 4 methods have the potential to violate this one. All right. So we have another preference table. You're going to get sick of preference tables by the time this is over. But you should be a pro at them by the time you get to your test. First, second, and third place votes. We have 4 voters that ranked A, then B, then C. We have 3 voters that ranked C, B, and A. And we have 3 voters that ranked B, C, A. So we have, 10 voters. By plurality, we're just looking at who has the most first place votes. Plurality doesn't need to be majority. A has 4 first place votes. B has 3. C has 3. So by plurality, A is the winner. But what if something happens? What if C drops out? All right. So if C drops out, our table now looks like this. That whole thing of losing voters. C drops out. We no longer have third place, so I need to erase that. Silly me, because C's gone. So we have AB, BA, and BA. All I did was remove C. AB, BA, BA. And you know what? Let's clean this up and let's make it 4 for BA. Let's just do 2 columns. It's easier. Because you had 2 columns, 2 and 2 for BA, so you might as well just combine them. All right, so what happens now? Biplurality, again. We now have A has 3 votes. B has 4. B has over half. Notice what happened there. A was the winner to begin with, but when C dropped out, suddenly B's the winner. Huh. This violates the irrelevant alternatives criterion. A was the winner until C dropped out. Now B is the winner. This violates the irrelevant alternatives criterion. So same kind of thing happened with the math. In this situation, when C dropped out, that affected the support. So it's a different criterion than earlier, but the same kind of pattern occurred, where when C dropped out, suddenly that support for C being gone bumped B up and gave it 3 more votes. So, you can no longer vote for your candidate. Who are you going to vote for? Well, sometimes it happens that the person who's not ahead all of a sudden gets those votes and becomes the one who wins. So that's the irrelevant alternatives criterion. So we did 4 criterion. Majority says majority winner should win no matter what, but sometimes majority winner doesn't win when you do it by board account. Head-to-head says that whoever wins a head-to-head comparison should be the winner no matter what. Well, of course, with the pairwise comparison method, that's not going to violate it. But with the other methods, it's possible that the same one who won by pairwise comparison may not win by one of the other methods. That violates head-to-head criterion. Monotonicity criterion. If somebody wins the first election, if there's 2 elections, and then they drum up more support, this says they should win the second election too. The only time that you'll be okay with this one is the plurality method. The other 3 methods could violate this. The person who won the first election, maybe by pairwise comparison, wouldn't win the second election, even after adding to their support. Because it all depends on what's happening with the rankings and the points. And then the irrelevant alternatives criterion. Winner of a second election should be the same as the winner of the first in the event that a candidate is removed. But all 4 methods have the potential to violate this, as we just saw an example where it got violated. So if you're the winner, they hold an election, you win. Somebody else drops out and they hold another election, this says you should win again. But if you don't, then it's a violation of the irrelevant alternatives criterion. All right, so we conclude with something that's a little negative. Arrow's impossibility theorem, named for Kenneth Arrow, an economist, who proved this theorem in 1951. He's very interested in voting theory. He's also interested in game theory, which is another kind of fun topic. We're not going to worry about game theory in this course, but go look it up. It's pretty fun. He liked to work on things like the prisoner's dilemma. He won a Nobel Prize in economics in 1972 for his work on the theory of general economic equilibrium. Another good guy to add to your mathematician list. But what does Arrow's impossibility theorem say? It is mathematically impossible for any democratic voting method to simultaneously satisfy each of the 4 fairness criteria. So if you have to choose among 3 or more candidates, no democratic voting method will always be fair. There will be situations where there's unfairness. The order choices of an individual cannot be accurately translated into the order choices of a group or society while also meeting these specific criteria. Feels kind of negative, doesn't it? Especially while we're holding an election right now. Different voting methods are used to try to balance things out and offset this impossibility theorem. And we'll look at a few things later in another video. But for now, these popular voting methods, none of these 4 popular voting methods are ever completely fair in every situation. You can thank Kenneth Arrow for proving this mathematically. All right. Well, thank you again for joining me. We're going to be wrapping up voting pretty soon with another video or 2 before we get into apportionment. So I look forward to seeing you again soon.